So we're going to start here talking about skeletal muscle and muscle tissue properties. We're going to do a little brief review of skeletal muscle tissue and get some terms down so that we are all using the same terminology in the appropriate manner. So let's start with some characteristics of muscles. Muscles are voluntary, which means that we have to somehow send an external stimulus in order to get the muscle to function. And it's going to function in the form of the motor unit within the muscle itself. The muscle itself is irritable, which means that it's going to respond to a stimulus. The muscle is extensible, which means it's able to stretch beyond its original length. The muscle is elastic, which means that it's able to go back to its original length after being stretched. The muscle is contractile, which means that when stimulated, when irritated, it can shorten or lengthen based off of what stimulus we are providing and the relative level of contractile strength being presented. And lastly, we have muscle that is plastic. And by plastic, we're talking about plasticity here. And that's the ability for the muscle itself to modulate its overall function based off of repeated exposure to the same stimulus. The response here is a homeostatic regulation, which means it's going to be governed by the said principle. In plasticity, the muscle is going to respond in such a way that it's going to meet the demand that's being placed on it. No more, no less. And we'll talk more about this when we look at the adaptations to overload and to continued work. Remember, when we talk about the muscle cell itself, we have a couple characteristics within the cell. First is that each muscle fiber is a cell that's going to run the entire length of the fascicle, and each cell is a single long cylindrical unit. The muscle cell is polynucleated, meaning that it has multiple nuclei. The muscle cell itself is amitotic. It will not divide. When excessive stress is going to require the tissue to grow, it grows by activating satellite cells, which will embed themselves into the muscle cell itself, generating a new myonuclear domain as opposed to the muscle cell itself splitting. And so muscle cells will undergo hypertrophication, getting larger, and atrophication, getting smaller, but it will not undergo hyperplasia, that is getting more muscle cells. When we talk about the cell, we change some of the terminologies within the cell, and we'll use the phrase sarco. So the sarcolemma is the membrane of the muscle cell itself, and the sarcoplasm is the internal regions of the cell. Within the sarcoplasm, we will have predominantly myofibrils, cytoskeletal proteins, either regulatory proteins, structural proteins, or contractile proteins that are going to make up the bulk of the cell mass itself. Most of the mitochondria and other organelles that we see in the skeletal muscle are going to be compressed to the lateral aspect of the cell itself, along with the nuclei. The amount of mitochondria that we see within the muscle cell itself is going to be dependent upon what type of muscle fiber cell we are seeing, based off of classifications of either energetics or twitch, based off of those characteristics, where the slow oxidative fibers will have a lot more mitochondria than the fast glycolytic fibers. In terms of function of skeletal muscle, we have two principal functions that we can look at here. We can look at movement and we can look at heat production. When we're talking about movement, we're talking about gross motor actions or fine motor actions. Gross motor action is where the entirety of the kinematic chain is moving, such as raising your hand to ask a question, throwing a ball, kicking a ball, getting up out of a chair. Those are all gross motor movements. Whereas fine motor movements are highly dexterous motions, such as writing notes, typing on a keyboard, sewing. Those are all fine motor actions. Or we can have what's referred to as postural stability. That's the ability to keep the articulations in a static position. The other thing that's going to come about from skeletal muscle is a large amount of heat production. Most of the heat that we have within our body is coming from skeletal muscle, based off of energy transformations within the mitochondria, or due to frictional components within the contraction itself. So before we get much further, we need to go ahead and talk about some of the terminologies, because the way in which we talk about some of these kinematics, these motion that take place within the muscles, is not the way that the terms actually should be used. Now, there's some terms in physics that we're going to have to pull in and remember when we're talking about the physiology of muscles. In the fitness centers and in the gyms, we may use these interchangeably, but the problem is that the way in which we use them interchangeably discredits what they actually are. And so we may say force when we're actually meaning strength. And we may say power when we're actually talking about intensity. And a lot of times we use intensity incorrectly, particularly when it comes into the realms of doing activity. Force. Force is measured by mass times acceleration. It's given the unit newtons. And this is when we have a linear motion. However, most of the motions that we have within our body are actually rotational motions. They're angular motions. And so we have to change force to inertia. And inertia is simply mass times the angular acceleration that's taking place. That is, how quickly am I changing the angles between the bones within the articulation. Work. Work is the force being produced over a given distance. Now, once again, since we're not moving linearly, we're moving rotationally, angularly, we have to change that from work to torque. And so torque is the angular force that's coming into play times the distance liver, that is the length of the limb that's moving. And this is where longer limbs will end up producing more work, more torque, than shorter limbs, simply because of the distance lever arm that comes into play. Power. Power is how quickly am I doing that work. We measure this in watts, where if I am linearly moving, it's simply the amount of work per unit time. Whereas if I am rotating, it's what is the torque that I'm producing relative to the angular speed at which I am moving. Intensity. Intensity is a measure of energy in the environment. We measure this as a candela, which is simply the watts, the amount of power that's there, relative to the area of movement. So a lot of times you'll hear people say, oh, that was a very intense action. In order to be a very intense action, we either have to have a lot of power in a very small area in order for it to be that intense. A lot of times when we talk about intensity of muscle actions, it's usually in reference not to this type of measure of intensity, but to relative energetics that come into play. That is, what is the metabolic equivalent of that particular event. The last is one that usually gets confused, and it gets confused with force, and this is strength. Strength is the measure of tension or compression that a given fiber has. This is how much can I stretch the fiber or how much can I compress the fiber before it breaks, and that's the yield load. Now, muscle fiber itself has a pretty consistent tensile strength, but what ends up happening is that as we increase the cross-sectional area of that muscle fiber, we get a larger tensile strength, a greater yield load that can be resisted. And so we have a relationship here. And the relationship is a direct proportionality of cross-sectional area to strength. Meaning that the larger the muscle, the greater the strength the muscle has. One other issue that comes into play, and we'll get more detail about this later on in our discussion, is the idea of tone. And tone is the percent of the muscle fibers being recruited in order to provide strength. Now, the other thing that's going to impact the functionality of the muscle is the shape of the muscle, what we describe as the pennation of the muscle. And the patterning of the pennation is going to influence the degree of force, inertia that can be generated, and the overall strength, the tensile resistance that that muscle has as it produces kinematic motion, in which convergent muscles of the body have the greatest strength ability. Parallel and circular muscles have the least amount